Okay, so we got different functions of f and g here, different pairs. For each of them, we're supposed to find f of g of x. That's how you'd say that. This says g of f of x. And what it means is you're plugging the function g into the function f. Or in this case, you're plugging f into the function g. So let's do this first one. F of g of x. All that means is instead of writing x minus 3, I'm going to replace this x with 2x with 2 minus 3x. So there's my x, and then there's the minus 3. I took the function f, and I replaced the domain variable with 2 minus 3x. And then we just got to simplify, right? 2 minus 3 makes negative 1, so this is negative 3x minus 1. That's f of g of x. And then g of f of x, this means I'm supposed to plug the function f into the function g. So here's the function g. I'm putting f into it right in here. Okay, so I'm going to need parentheses there because the entire thing needs to be multiplied by 3. So I'm copying down the function g, the 2, the minus, the 3, and then when I get to the variable, I'm stopping, and in parentheses I'm going to put what f is, because that's what this notation says. You're putting f in place of where the letter x would normally go. You're plugging this entire thing into the letter x, right? And f of x is x minus 3, so that's why that went there. And then you just need to simplify. So distribute that, negative 3, so that's 2 minus 3x plus 9. And then we got 11 minus 3x, I think, when you combine. I did that a little fast, though. So, okay, that looks good. All right, they asked for the domain. Look, here's the first function, here's the second function. They both have the same domain. It's all real numbers, negative infinity to positive infinity. There's no problems. There's no divide by 0 problems. There's no square root of negative problems. So we're all set with both of those. Okay, so on to the next one. As Jay-Z said, I don't know what he was referencing, actually. Maybe I shouldn't say that. Maybe it's something bad. F of g of x. That means I'm plugging g into the function f. So I'm plugging g into the function f. So the function f is a square root, but it's supposed to be x squared plus 1. Look, you can't actually simplify anymore. There's nothing else you can do. It's not square root of x squared plus square root of 1. When you have a square root, the entire thing needs to be resolved first. This is where we have to leave it. I know it's tempting to make that square root cancel out the square, but we can't do it. Okay? If it was by itself, if it was just x squared, then it could cancel out. Look, the domain for this one is all real numbers. You want to avoid square rooting a negative, but there's no chance of having that because think of the sign here. This is always positive. So there's no way you can square root a negative. So all numbers are fine. And then we're supposed to do the opposite. G of f of x. So I'm plugging the function f into the function g. So the function g says x squared, but I'm going to replace x with square root of x because that's what f is. So I replace this x with square root of x. That's how you plug f into g. I took f and I plugged it into g here. And squaring a square root, those two things can undo each other. Let me think here. But if this is where we leave it, this is g of f of x. The domain here needs to be just bracket 0 to infinity. But if you resolve that square root in the square, this would be x squared. This would be x plus 1. And that domain is negative infinity to positive infinity. Okay, but watch out for that. This is g of f of x. The domain here has to be 0 to infinity because you can't plug a negative into a square root. Okay. So whether you simplify or not, you have to do what the notation says first. G of f of x. So that domain is what I said. That's a finer point that's usually not, that doesn't come up very often. So don't be worried if you're not sure what that means. F of g of x is the first thing we're supposed to do. We're supposed to plug the function g into the function f. So here's my function f. I'm copying it down, and then when I get to the letter x, I'm going to replace it with g. Oh, and isn't that ugly? Okay, I can simplify a bit. I can multiply 5 over 1 to that fraction. That's 1 over 5 over 2x. But another way of writing this is as a division statement. This is 1 divided by 5 over 2x. So 1 divided by 5 over 2x. Okay, and if the x is written to the side, oh, wait a second. I did that wrong. I'm sorry. That's 1 over 2 with x clearly in the denominator. I'm such an idiot. There we go. Okay, let's redo that. That's 1 over 5 over 2x. So this is 1 divided by 5 over 2x. Same thing, right? I just used a different division symbol. But now I can flip and multiply that second fraction, 2x over 5. Holy cannolis, because that's going to be 2x over 5, right? So there's a lot of fraction flipping going on there, but that's our final answer. We've simplified. F of g of x is 2x over 5. And g of x is, we're supposed to do g of f of x. So it means I'm plugging f into the function g down here. Okay, so g is 1 over 2x, but instead of x, I'm replacing it with 1 over 5x. And then we can do the same thing. That's 2 over 1 times 1 over 5x. That's 2 over 5x. And just like I did in that other problem, am I giving away the answer? Kind of close. Just like I did in the other problem, that's 1 divided by 2 over 5x. So we flip and multiply the second fraction. So this is what you should get.